Hello, welcome to TechMind Fundamentals YouTube channel. In this video today we will learn about the yield return and yield break. So this is most commonly used in case of iterator and when we work on IEnumerable and IEnumerator. So if you are working on these iterator or collection, these uh, keyword yield return and yield break uh, play a key role in uh, filtering the record or implementing any logic which use the iterator. So in this video we will also see how this yield return is different from normal yield return, and also how the yield break is different from a normal break statement. So before going forward on this yield return, to understand this yield you have to understand IEnumerator first. So I hope you have worked on data reader in SQL data reader, how the SQL data reader work. It is connected architecture and it is forward read only. So whenever you read the data from database using data reader, it reads data and it transmit it to the output stream or wherever you want to store that, right? It not pull all the data at one go and load into the data memory. It fetch and display data one by one instead of loading all the data from the database into memory. So on the same pattern this yield return works. It does not return all the data from the method. Instead it returns one record or one item at a time, but its return type is IEnumerable or IEnumerator. So this yield return is a contextual keyword. It is introduced in C# 2, and since it is a contextual keyword, there is no meaning of this yield keyword alone. When it is used with break or return, only then it has a special meaning. Otherwise there is no meaning at all. So that's why it is contextual keyword. When it is used in any context, only then it has a special meaning for the compiler. Whenever uh, it is used, it indicates that the method or the accessor containing the yield keyword is an iterator, method or accessor. So this yield can be either use any method or get accessor. I will show you that as well. An iterator, method or accessor is one that does not return a single value, but it returns a single value at a time. See, this statement is contradictory. What I am saying, does not return a single value, it means it returns multiple value, right? But it returns a single value at a time. This statement says that it will return one value at a time, but it returns all the value in sequential manner one by one. So the consumer of this iterator will have to implement the logic to get the data from this. It means that will use loop, whether for loop or for each loop, to read the value one by one from the iterator. Whenever the compiler encounters the yield keyword, it knows the method is consumed by an iterator. So both the method which contains this yield keyword is also an iterator, and the caller who is calling that iterator method, that should also be an iterator. So there is mutual understanding between those caller and callee, that I am calling a iterator method, so it must be a iterator as well to consume the response from the iterator method. So before going to the yield demo, I have to explain about the IEnumerator. So I have defined a list here, or you can say a list of integer where I have initialized 1 to 10, right? And now my requirement is I have to print the even numbers from this list. So what I have to do, if I want to print that using uh, list, because this is this, so it will you can think that IEnumerable or list. So this way you can print using the for each loop, right? If you run this, it will print the even numbers from this list. If you see, this is a list, or you can say IEnumerable. IEnumerable is also forward read only, where the list is not forward only. You can add, update any record into the list. If you see here 2, 4, 6, 8, 10, these are the even numbers, right? But if you have to do that using IEnumerator, so IEnumerable internally use IEnumerator. So this is the list. Let me go and get the enumerator from this list. So let, if you put dot here, list, you see that as enumerable, and this enumerable internally use enumerator as well. So to get the enumerator, this is the method dot get enumerator. Now this, if you see the type of this IE, it is IEnumerator type, and this IEnumerator has, since this is an interface IEnumerator, so there are some method which it implements. So to print the even number from this IEnumerator, what you have to do, this is the logic. So to read the value from this IEnumerator, you have to use move next, and this is under a while loop. It means while there is element in I dot move next, you have to loop this logic, and under this logic I have written if I dot current, and this dot current method, it is used for getting the current value in this move next. Move next, what is the current value under this IEnumerator, that will be picked up, and it will uh, checked against this logic, and if it is true, it will print the value. Let me control F5 here, same 2, 4, 6, 10. Same thing you can use the IEnumerable and IEnumerator. So now the question is, what is the difference between these two, IEnumerable and IEnumerator? If you are using IEnumerator, in that case you have to check additional thing, while, then move next, then current, all these things you have to check. It means it involves some extra keywords hit in order to implement the same logic, right? So the difference between these two list, IEnumerable and IEnumerator, is that the IEnumerator preserve state. It means for stateful iteration we use IEnumerator. Let me show you how. So for example, in this list, if I have to print all the numbers, right, and I have written two methods, one will print first 5 and second have to print the next 5 element, right? So if you do that using IEnumerator, I will show you this print method, print a method, and this will, here I am passing the IEnumerator which I have defined here, IEnumerator, right? and this is my print a method. It reads C receive IEnumerator of integer, and from that I have written this logic collection dot move next. It is, you can see it reads head, the head element from this move next. It will use to rotate the next element in the list. Move next, uh, if you have worked on linked list, then you can understand this, uh, what is it works basically. Move next and current, in the current head it will work to fetch the next element, and this will read the current element from the IEnumerator collection. So here move next, and if collection is now, here I have written the logic if current less than equal to 5, which is checking the value. If current value is less than equal to 5, then print. If the current value is greater than 5, in that case pass the current collection to print b method, this print b method. And you will see that whenever this method pass the collection to this method print b, it will preserve the state. It means whenever it completes the 5 numbers printing, then this method will start printing from the 6th element. Now let me run this program and I will show you. See here, from print a method it prints till 5, right, a5, and after that when it pass here, when it pass the data, this list IEnumerator list or collection to print b method, it preserves the state from where this print method have to print. So the complete stack trace, from this method, or you can say complete state of this method, this IEnumerator will be passed to this next method. Not only the list, not only the IEnumerator collection, but it will send the state of this uh, IEnumerator as well to this print b method. And if you see here, the print b method start printing from 7, 8, 9, 10 here. Now one more thing, the IEnumerator method used the reset method. There is a reset method in IEnumerator, and when you use that, it will reset the state of this IEnumerator. Now since you have reset the state of this IEnumerator, control F5, it does not preserve the state, it reset the state. And see, the print a method prints from print till 5, and after that when it pass the collection IEnumerator collection to the print method b, since I have reset the state of this IEnumerator, it does not understand from where it has to pick the next element, and that's why from print b method it starts from 1 to 10 again. So this reset method does not used by the iterator, where we used yield return. I will show you that. So let me comment out this method. So this is the IEnumerator. It is used for stateful, or you can say preserve the state of iteration. If there is a need that you are using multiple method where one have to preserve the state, and then from next method you have to continue afterward, right? So you can use this IEnumerator because it preserves the state. Now till now we are fine. So now coming to the yield keyword or yield return, it you can think it like a go to statement which returns and then go to. So before going forward, let me show you what is the go to statement and how it works. Go to statement is nothing but it will use to jump over on any place in the code. So if you are a C or C developer, you will understand that what is the go to statement, but C sharp also support the go to statement. So for example, from this list, if you have to print the first even number, as soon as you get the first even number, you have to jump out from this list, or from 1 to 10 range. I have to check the first even number. So this is the method which I have called from here, go to demo, and here I have written a logic. If I percentile 2 equal to 0, it means when it founds even number, then I have told go to display, and display is nothing but variable name here, you can say indicator or location, or in the terms of this C sharp you can tell this is a label display. This is nothing but a label. So go to display, whenever it encounter this condition, it will jump out to this location, and from there it will continue, otherwise this method is. So that's what. But here let me first run this program. Here it is printing 0, no matter, but whenever, as soon as it get the even, as soon as it get the even number, here it jump out to display and it prints the even number. And the first odd is 0 here, because I have used this num and I am assigning this num here, so you have to use I instead of num. Now it will print 1. If you press Ctrl F5, now you can see here odd, 1 is odd and 2 is even. As soon as it get the even number, it jump out to this display block or display label, and it will continue from there. But there is no way to go again here, right? But in case of yield return, that is the beauty of yield, it jump out to here where that method is being called from the caller, and after that it will go again and to and fro from this method. Now I will show you the first enumerator iterator. I have created a accessor, get accessor, and this get accessor, this is my user class, and in this user class I have defined role, and this return type is IEnumerable, and this get accessor, because I have told you that you can use yield return or iterator only in get accessor or in a method. So this is the first thing I am demonstrating this in a get accessor. This is get accessor, and yield return new role, and this is the role class here. When you hit this get accessor from this, suppose this is my calling method, main method, and see I am using for each here, but in this it is returning, since it is returning role here and that is list, but whenever this statement execute, it will return one value at a time. It means this will be written first, and this will be printed out here. This line will be executed, and again it will go back here, and this statement will be written, yield return, and that will be read by here, this role is assigned to this role, and it will print that value. Let me run this. See, you are getting all the role ID and name here, but I will show you. For this is the get accessor, but how it is work I will show you in the next demo. uh, Let me comment out here this code, and table. For example, I have to print some table for of any number. So this is our table method, and the type, if you see, IEnumerable and IEnumerator. For example, I have to return print 1 to 10 number here. So how it will print the value here, if you see, I am printing 2 multiplied by number. For example, here I am printing the table for 2, and whatever value we receive from this number, num is here, and from this table iterator method, this one, I let me run this program here. For each and every value, you will see 2, 4, 6, 8, 10, 12. So it prints the table for 2, and you will wondering that how it prints the value. If it returns all the value at one go, then if you see here, it is not like that. So let me write a line here, yield return console dot write line, and here I will use I equal to, and here I will assign the value as I. Now if you run this program, now you will see the value, how it work. First iteration I is equal to 1, it returns the value of I to the caller, and that caller prints value 2, and in the second iteration I is equal to 2. After sending that value, the control pass to this again, and it print the I is equal to 2 here, and 2 is passed to the caller. So 2 multiplied by 2 is equal to 4, and next iteration when it came to this loop again, I is equal to 3. Similarly, if you see, for each and every time it is incremented by 1, 1, 2, 3, 4, 5 till 10, then it returns 1 by 1, not all the value at one go, and at last yield return for table is completed. Now, so one more thing I would like to tell here, yield, whenever you use this yield, so there are some rules which you have to follow. The return type must be IEnumerable, IEnumerator, or async enumerable. These may be generic or non-generic, or you can say the custom IEnumerator or IEnumerable type, or system defined type, for example integer, uh, decimal, string, whatever. So the return type must be this. So in this you can see this I am using IEnumerable. This is the first rule, And the parameter iterator method cannot have any out, ref or in parameter. So here you cannot use any out parameter, out int x for example. The out parameter x must be assigned, but iterator cannot have ref or out parameter. So since this is an iterator, how the compiler know that it is an iterator? This is IEnumerator and there is see the yield return. This yield return make the compiler to understand that this is a iterator. If you see the error message, out parameter x must be assigned before this, but if you try to do for example x is equal to 5 here, but still iterator cannot have a ref or out parameter. So you cannot have any out, ref or in parameter. If you are new to my channel, I have already posted a video on ref versus out parameter versus in parameter. You can find the link of that video in the description. And place, an iterator cannot occur in any event constructor or static finalizer. So you cannot put the iterator or this yield keyword in any constructor or event because it returns a value, right? So constructor cannot return a value, that's why you cannot use that. An iterator can only occur as a method or get accessor. So we have seen in get accessor as well here and in the method as well. This is the method. You cannot include a yield statement in a method that contain unsafe block. Unsafe block is used normally when we work on pointer. If you want a video on this unsafe block, I will post that video. If you want, you please do comment. You can't include yield statement in lambda expression or anonymous method. You cannot use this in anonymous method, and we know that this lambda expression used anonymous method. And exception handling. So here for example, if you have to handle the exception in case of iterator, so a yield return statement cannot be enclosed in a try catch block. So this is the first place where you cannot use catch block. In C# we know that we use try catch block for handling the exception, but iterator, in case of iterator, you cannot use try catch block. For example, if you want to push catch here, exception, you will get an error message. See, cannot yield a value in the body of a try block with a catch clause. So you cannot have catch block in case of iterator method or yield return, but you can have try finally. But a yield return statement can be enclosed in a try finally block. But if you have this finally block, then what are the condition when this catch block is this final block will be executed? So the first case, when after the last statement of the try block is executed. So whenever the last statement of this try block is when the I is less than or equal to 10. It means at 10th iteration it will complete this try block, and after this final block will be executed. That's what you have seen. At 10th iteration yield statement is completed, this statement is printed from this finally block, right? When an exception propagated out of the try block, For example, if you have some exception, let me print where x is equal to 5 by 0, convert I am converting 2 int 16 and the value is 1x. So we know that I am converting this to integer, but I am passing some alphabetic character here. It will throw an exception, and if you run this, see what happened here. One iteration is completed and one is printed. When in case of one iteration, it will pass to the caller, and the 2 is printed because 2 multiplied 1 is equal to 2. And after that, when the control came back to here, it finds this statement, and since this is causing an exception is printed here, and after that, see, yield return for this table is completed, this final block is executed, right? And when execution leave the try block via yield break, now I am using yield return here. If I is equal to 5, yield return, I will put it here, right? What I am trying to say here, yield break. If I is equal to 5, this loop will be terminated. This iteration basically will be terminated. If you run this, as soon as the I is equal to 5, 1, 2, 3, 4, as soon as the value become 5, it returns. If you see it, the 5 is not printed here because before printing this condition is encountered and it terminate the iteration. And after that, you can see the final block is executed. And the last case, when the iteration is disposed and the iterator body was trapped inside a try block at the time, at any time. Similarly, since here you have used try block, this exception caused this final block to be executed, as we know. But what happened if there is exception in the caller method as well, right? See, there is no dependency on this method. There is nothing wrong in this iterator method table. But since here we are generating an exception here, what I am trying to do here, if number is equal to 5, I am trying to convert divide by 0 exception, num divide by 5. It will cause divide by 0 exception here. So do you think that this finally block will be executed? Yes. Where? Because this exception will be propagated to this table method as well. Why? Because we know there is one-to-one communication between these two, table and that table method and this for each loop, because this table method or iterator returns one value at a time. Since it is completed till 5, when control jump back after printing 5 multiplied by 2 is equal to 10. After printing 10, it encounters that there is exception, but control goes back to this method with exception, and that's why this iterator will be disposed and finally block will be executed. Let me run this program. See, after printing 4, yield return for table is completed. This finally block is executed and loop is terminated. Let me comment out this. Now see the error message here. Till 5, 10 is printed in this statement. As soon as the number is equal to 5, because the table iterator method returns 5 here, and after printing 10, it encountered this statement, number is equal to 5, and exception is thrown. Since this exception is propagated to the table method as well, the loop iteration will terminate it and it prints the finally block. Now how these are happening? So let me show you the IL code, how this yield return work. So the way of working or technical implementation, the yield return is basically a syntactic sugar over IEnumerator. So the yield return which we use, it is nothing but a syntactic sugar over IEnumerator. When you create an iterator for a class or a structure, you don't have to implement the whole IEnumerator interface, because IEnumerator contains a lot of method. Let me show you if I am able to. So I will show you the IL code for this. For example, to see the IL code of this program, you have to go to Visual Studio, developer command prompt, and the tool name is ILDASM. ILDASM. This will ask for the path name where your exe or DLL is. So this is yield statement bin debug yield statement. Now let me see this table iterator. This is program, because I have placed all these method under this program class. This is table method, table iterator. But if you see closely, there is one more class which is generated by the compiler. This is the table D_6. So whenever the compiler encounter the yield return keyword, it generates all the it implement all the required method which is defined in the IEnumerator. So this is generated for this table IEnumerable method. And if you see here, this table method program slash table D_6. So that's what this is, a method which is generated by the compiler when it encountered a iterator. See here, nested private sealed method, and that's what I am trying to say here. When you create an iterator for a class structure, you don't have to implement the whole IEnumerator interface, and this compiler generate all the method here. If you see here, IDisposable here, it implements IDisposable, uh, IEnumerator. It creates variable to preserve the state which are used in IEnumerator. See the current state and current, these two variables are created to maintain the current state and state. Initial thread which start the thread, and private variable which is used for within this iterator, and final block is also there. And this move next, I have shown you this move next in the IEnumerator demo. We use this move next to go to the next element in the list. And similarly, get enumerator, this is the method which implement, and get current which we have used, if you remember, in this print method here. Move next, get current, IEnumerator. So that's what the compiler generates for us automatically, right? And reset, this is the reset method which I have used in this here. If you remember, I have used this reset, that is the method in the IEnumerator. This reset method is there. Get current method is there, that returns object. Get current is nothing but returning the object in the current on the current node. Similarly, if you see IDisposable, that dispose is also implemented there. Current, instance, generators, all these required method from this IEnumerator is implemented by the compiler. So these are the things which are created by the compiler for you when you use yield return, and these or collection make the stateful iteration, you can say the state machine. So that is the working mechanism in C sharp. The C sharp code containing yield is not directly executed by the runtime. It means the code which you have written, this code, it is not directly executable by the compiler. Compiler have to do a lot of things for you in order to execute this statement, and this is only happen due to this yield return keyword. This contextual keyword yield make the compiler to understand that he has additional responsibility to do these things. It will create this uh, virtual, you can say virtual class behind the scene for you to implement the stateful iteration or state machine, and that will be used instead of this. Here it has nothing, it creates new object. If you see new object, it will create the new object of this, and this is the object which is created. This is the name. It appends something random name for d underscore underscore 6, so that it keep such a name that that is cannot conflict with your user defined name, and it also have some constructor. And system.runtime.compiler service iterator statement. You see here why I am saying this is state machine, iterator state machine attribute. Now the compiler know that it iterator state machine attribute, it means it will implement all the things which is required for state machine. System.type yield statement. So this is done by the compiler, and let me, the compiler transform the code before the runtime ever occurs. So this is what the compiler does before execute before the CLR execute that yield return method or iterator. When you write an iterator as a method, the compiler translates it into a nested class that is in effect a state machine. This is the nested class. If you see here, ANSI shield before nested. This is the nested private, and it implements extend system.object, implement what are the IEnumerator, IDisposable, IEnumerator. These are implemented in this nested class. These keep track of the position of the iterator as long as for each loop in the client side code continues. When the compiler detects the iterator, it automatically generates the current, move next, dispose, enumerator or IEnumerator interface. So that's what you have seen here. It generates current, state, and move next, everything. It dispose method here. It generates all the thing for you. Yield return is similar to a return statement followed by a goto. That's what I have already explained in the starting of this video. So these are the things behind the scene when you use the yield return. Yield break is used to break the iterator. Now coming to the next point. So in the rule, there are some also two rule pending which I have not explained. A yield break statement can be enclosed in a try block or catch block but not in a final block. Yield break statement cannot be placed in a final block. In this program, if you want, if you see in this table, yield return and yield break, if you try to break the statement here, it will not work, cannot yield in the body of a finally class. So as a developer, you know that we use this final block to clean up the resource, right? So if you want that, you can put this yield break in the final block. So you cannot do that. It can only be in the try block, either here or anywhere. So you cannot put it in the final block. If the exception happened in the for each body or for body of the caller or consumer, the final block of the iterator method is executed. We have seen that, right? When we generate the exception from the main method in the for each loop, this exception is propagated to the iterator method and the final block is executed. Iterator don't support the IEnumerator.reset method. IEnumerator.reset method is not used in the iterator because it is not implemented for you. And whenever you want to reset, calling reset on the iterator returned by the iterator method throw an not supported exception. If you try to use this reset, as we have seen in this method here, if you remember, print this reset method. This is the IEnumerator collection, and here I have used this reset, but you cannot use this in the iterator. If you try to do that, you will get exception, not supported exception. And if there is a need to start from the beginning, you must obtain a new iterator. It means you have to call this method again, right? Yield break. The yield break statement is used to end the yield return state iteration at any time. Whenever the iterator found yield break, it will terminate the iteration or enumeration. Normally, a normal break statement which we use in the loop, it terminate the loop, while yield break terminate the yield enumeration. Now I will show you that how this yield break terminate the complete iteration, because uh, it is one to one calling for each and every value. It call the iterator and it is consumed by the caller or consumer. For example, I have written a simple example for calculating the power. 2 to the power 5 here, and it will print each number. So this is our power method. This is the power method which I have created. Number and exponent, and this example I will show you that whenever the control came here, this integer result, this line will not be executed again and again. It means this complete method is not called again and again. Only the control from this loop will be go to the caller method and return back again, until and unless the caller is calling, or you can say if the caller satisfy any condition, till then this iterator will work here, or if there is a yield break in this iterator. So here I have print the message here first, and after that for each and every iteration it return the value to the caller, and at last this one. Now first let me run this program here, then I will explain how it work. See, power method is executed with parameter 210. The parameter which passed here by the caller, 2 to the power 10, 2 and 10. The first, when the it encountered the first statement and the print statement, power method is executed with parameter. This is printed. Power method is executed with this parameter, and result for I. Now this result for I, the first statement, the result for I is printed here. Result for I is equal to 0 is 2. Value of I after yield return is 0. Value of I after yield return is I. Why? Because in the first iteration it is I is equal to 0, starting from 0. That's why we are getting from 0. And the second iteration, when this 0 is returned from this method to this caller, and that value is printed here. So that's why see 2 is printed, and again after printing this value, control came back to this here statement in this loop, and again it will print result for I is equal to 2, because I is equal to 1, because now the I is incremented by 1. Result for I is equal to 1 is 4. 4 what is 2 multiplied by the value which is number, that is 2. 2 multiplied by 2 is equal to 4, and 4 is returned back, and again similarly I equal to 2 is 8. 2 multiplied by 4 is 8. Similarly, because this value, I am showing you result multiplied by number, and result previously the value of this result is preserved. It is not being reset again and again. It means these lines will not be executed again at any iteration, what will be continue? This body, this for each body a statement will be executed again and again. That's why you can see here I am using getting this statement result for this and the value for I after this statement. Only the body of this for loop is executed again and again, but before that all the statement will not be executed again and again. So one value is completed, it will pass to the caller and again it control back. This line is printed, the control is when this yield return statement found, it will return the value to the caller. See, the value is returned and this 4 is printed by the caller, and after that when control came back it prints this line console dot write line value of I after returning this statement. So this statement is printed by in this iterator, and this is printed from the caller method, and this, so one by one it is printing the value, and at last if you see result for I is equal to 9 is 1024, and 1024 is returned back to the caller, and the caller print this 1024, and when control came back to this iterator again it execute this next statement, that is this one. So this is how the iterator or yield return work. Now in this case, if you want if when I is equal to 5 I have to use yield break. For example, if we comment out this, here I want if I is equal to 5 I have to break this loop, otherwise it have to return the value. It will work same as we have used in the previous example as well. Whenever the control finds this yield break, it will terminate the iteration or enumeration. See, till 4 it is printed and the value is returned back, right? Whenever I become 5, the result for I is equal to 5 is 64. This statement is before this yield break, so that's why it is printed 64 I is equal to 5, but when it encounters I is equal to 5 here, yield break is executed and loop is terminated. And since the loop is terminated, this last statement is also not executed here, because as soon as it compiler or CLR encounter this yield break, from there it will discontinue or terminate the loop. No code after that will be executed. So that's why at last this line value of I after yield return is not executed anymore, right? Similarly, I have also written some more example. For example, in the list which we have defined in the beginning 1 to 10, this 1 to 10, suppose I have to print the even number from this list. So I have created a even iterator here. In this iterator, so for example, if you want to return all the values from here, this collection even value, right? So normally what we do as a link to, we use this return collection dot where, right? As a link to developer, you can use this collection dot where r equal to r tends to r percentile to equal to 0. So it will check for the even number and it will return. Since this is IEnumerable, cannot return a value from an iterator. Since this is an interface, IEnumerable is interface or IEnumerator is interface, so that's why we are getting this message cannot return a value from an iterator. Use the yield return statement to return a value or yield break to end the iteration. So you cannot return a list or value directly in this IEnumerable. what you have to use? You have to use IEnumerator. uh, in case of IEnumerable or IEnumerator, you have to use yield return or yield break to terminate the loop. Let me put yield return. If you put this yield return here, but see the message, cannot implicitly convert type IEnumerator integer to int. Now there is problem here. What is the problem? Since this method returns IEnumerator, I have put this yield return also here, and this method it also returns a list, right? This method returns a list, so there should not be any problem. But see the error message to integer. So the problem is, since this is an iterator pattern and this yield return, this yield keyword, it returns one value at a time. It cannot return a list, or you can say the multiple value at one go. What it expects, since this IEnumerable is of type integer, so it expect one value, you can say one integer value at a time. But what I am trying to do here, it returns multiple value, which is, if you can, if you want, you can typecast it to IEnumerable as well. But in this way you will not be able to return all the value at one go. That is the beauty of this yield return. It does not require all the value in the memory to be returned, as the same way I have explained in the video that SQL data reader, how it work, it fetch one value and it put it to the output stream to display on the screen. So similarly here it will return one value and it pass to the caller, so that that caller can continue with that value, and after that when it come back again and execute the logic, send the second value. So that's why you are getting here error message. It is trying to send one value to integer, but it returns IEnumerable here. Now let me return 1. See, there is no issue. It can return, it will return 5. But now if you comment this, see, do you think that a lot of time the interviewer or in the online test this question is there, if you this whether this statement is valid or not? The normally developer confused that since this is IEnumerable and I am returning just a single value, what is wrong with that? Let me first run this and you will see here you are getting value 5 here. How it is happening? Our return type is IEnumerable, but I am returning a single value and it is working. It returns 5 and that 5 is consumed by this caller. Whatever value we are getting, we are just printing that value. So how it is working? It is nothing but this yield, and the yield return guarantees that it will send one value at a time. It doesn't care about what are the value it has to send to the caller. So it is perfectly valid. Though the return type is IEnumerable, since you have used yield return, it will return one value. Now coming to the point, if you have to print the even number from this list or collection, so if this collection is null, you can return yield break. That is not required, but for your understanding I have put it there. You can do this as well. Otherwise, this is the, and also think one, if you are using this collection and somewhere if you anybody reset or you can change this collection value, since if you remember, this is the reference type, right? This collection list or anything, there are reference type. So if someone goes and change this value, and since this state is preserved here, so it preserve all the things internally, so whatever this changing, it will not reflect there. So this statement will be checked, num percentile 2 equal to 0, it will return the value. If you run this program, 2, 4, 6, 8, 10, these are the even numbers. Now similarly, I have used one more best example of this enumerator or iterator pattern to print the Fibonacci series. Fibonacci series is nothing but then it requires two number, first and second, and the third number will be sum of previous two number. For example, first number is 0 and second one is 1, then third number will be 0 plus 1 is equal to 1, and next element will be 1 plus 1 is equal to 2. So that's like it will work. So I have used Fibonacci series and I have defined a method. The consuming process is same as we have seen in the earlier example as well, and this is the Fibonacci series. So first let me explain the logic. Previous Fibonacci series and current Fibonacci series, this is the two number, the initial number from where we have to start the series. So I have used 0 and 1. If you required, you can pass this value in the parameter as well, but for demonstration I have initialized in this body as well, right? So these two are initialized in this loop, and you will be wondering that why I have not used this outside the block. So this I have to consume this value. I will show you that I is equal to 0, and this will variable will work for loop. I is less than to max number. This max number control uh, where I have to what is the maximum number in this Fibonacci series. So that's why, for example, 10 user have passed 10, so I have to use this 10 iteration, and I plus plus, this is the for loop syntax, and these two variable is there, and the logic is it will return previous Fibonacci. Each and every iteration it will return the previous Fibonacci series, previous Fibonacci number here, and here I am using just swapping. I am adding these two number and I storing into temp variable, and previous I am assigning current value in the previous, and in the current I am using this temp. Temp is nothing but this sum of these two number. So let me run this. Till 10 I have to print the Fibonacci series. If you see 0 plus 1, this 2 0 1 is the initial number, 1 plus 0 is equal to 1, 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 3 plus 2 is equal to 5, 5 plus 3 is equal to 8, 8 plus 5 is equal to 13. That's the series goes on. Now you know that how the iterator work, right? Let me show you the next thing, or you can say the next point of this iterator. Use or purpose. What is the use of this yield? I have explained a lot of application or use of this yield return or iterator pattern. The yield keyword perform custom iteration and get accessor without creating temp collection. So if you remember, in this case I am using this yield return each and every time. Otherwise what you have to do, you have to create a temp variable for this role, and again I have to create new role and add this to the temporary list, right? as a normal list, what I am to do, I have to create a list, empty list variable, and in that I have to add this new role list dot add, and in that I have to use this. But this yield return prevents that without temp collection. The yield keyword perform deferred or lazy execution. So deferred and lazy execution, what is that mean? So it only execute when required and when the caller want that. Let me show you. I have implemented two method, generate number with yield, generate number without yield. So here I am using yield return, and this is infinite loop. Infinite loop is here as well. So here where I is equal to 0 and I have assigned while true, return plus plus I. It will return the value of I after incrementing 1 again. And in the second, what I am trying to do here, I am using this list, first created a list variable, and I am adding value into this list while true list dot add return list. And since we are using Visual Studio 17, now the compiler is much capable to understand this logic what I have written. That's why it is showing me this unreachable code detected. How it understand that unreachable? Because I have used while true. It means this condition will never terminate, and at the end of the day it will cause stack overflow exception. But the same logic, infinite loop, I am using here, and these both method I am going to call. That do you think that these both statement will behave similarly? I don't think so. So first I will show you without yield statement, and from that first let me print that value without any filter. If you print this, execute this program, it is trying to add that value into the list, this, see, unhandled exception, out of memory exception. Memory is full means RAM is the complete RAM is allocated for this app domain is completed full, stack overflow exception. But now let me put a condition here. In this list I want only 5 number. Do you think that this statement will work here? It will not work, because this is not a lazy loading. The logic which you have written here, this is not a lazy loading or deferred execution. Yield statement has stopped working. Again it caused the exception, memory overflow. Now let me do the same thing using yield. So this is our yield implementation. As soon as the one value is there, it will be written again, and again this value is incremented and returned. So let me comment out this line here. Now the same thing if you try to do using yield first. Now if you see the series, now we are not getting exception, it is printing all the numbers till the maximum limit of this integer number, right? So there is no issue with yield return because it used deferred exclusion. Till then, this application, there is no constant here. The consumer is getting all the value. Consumer means this our for each loop. Now let me close this. Now this consumer or caller specify that I want only 5 value out of the iterator or enumerator. So now since I have put it a constraint here, see here, lazy exclusion. So though I have written a logic here to return the value, infinite value here via this loop, but the consumer wants no, I do not want the infinite number range, but I want only 5 out of all the numbers. If you run this, the iterator method will execute only 5 times and the iterator will terminate after this condition. Since now the condition is satisfied from the caller, there will not be no more iteration. So this is the beauty of this yield return. So that's what the yield keyword perform deferred or lazy exclusion. It exclude only when required. Useful to do stateful iteration in a quick way. I have shown you that how you can use stateful iteration. It is a very quick way of implementing the iterator pattern where both caller and callee are an iterator. In this case, you have seen that both caller and callee are iterator. Why it is iterator? Because it iterates over this number, and this method is itself iterator. So that's all from today. I hope you have enjoyed this video. If you have learned anything from this video, please subscribe to the channel and don't forget to like and share this video. Thank you very much.